Hey everyone, welcome back for another deep dive. We're tackling something pretty essential to your work today as software engineers, the evolution of AI-assisted coding.
Yep, that's right.
We've got a really interesting mix of sources for this one. Historical overviews, some deep academic papers, and even some thoughts from folks out there in the industry.
Should give us a pretty good view of the landscape.
Totally. And our goal here is to really trace how coding assistance has evolved, from the very earliest tools to the powerful AI stuff we're seeing today. And we want to do it in a way that's relevant to you as professionals. We're going to get into the nitty-gritty details, the little things that change how we write code, and also tie it back to the bigger picture.
Right, because it's not just a timeline of tools, is it? It's how programming itself has been reshaped at each stage, right down to how many keystrokes it takes or how much brain power you need.
Exactly. So let's start by rewinding way back, like mid 20th century. Can you imagine having to code in pure machine code? Every instruction, just bare metal manipulation.
Oh, I can try, but honestly, the level of manual precision, the potential for these tiny errors that could cascade, it's mind-boggling.
It really is like you had to be practically wired into the hardware itself.
You basically were. Every memory allocation, every jump had to be spelled out explicitly. But then things started to shift. The 1950s saw the arrival of high-level languages, and Fortran, which IBM released in '57, that was a huge turning point.
Yeah, Fortran. Short for formula translation, right? But it wasn't just about writing less code, was it? Our sources say it actually democratized computer programming. I think we need to dig into that a bit. How did switching from machine code to something like Fortran actually change who could program and what they could focus on?
It's a massive shift. Think about it.
Okay.
Scientists, engineers, they could finally express their problems in a language that made sense to them. Formulas, equations, instead of wrestling with the machine's guts. They didn't need this deep understanding of the hardware anymore.
So they could finally concentrate on the problem itself.
Exactly. And Fortran was smart enough to automatically translate all that into efficient machine code. So this newfound accessibility didn't mean sacrificing performance. It opened up programming to a whole new world of people.
And this idea of translation, it reminds me of Grace Hopper's work in the early 50s. Her compiler-like tools, like the A0 system, those were some of the first attempts to automatically convert human-readable instructions into something a computer could actually execute.
Absolutely. They were pretty basic compared to what we have now, but they represented a huge shift in thinking. It was like, wait, the task of translating human thoughts into machine code, that could be automated too.
So programming wasn't just this manual, low-level grind anymore.
Right. Tools to take on some of that burden. It was the start of augmented programming.
And then as we move through the 60s and 70s, more high-level languages pop up, COBOL, ALGOL, C, each with its own strengths, but all further reducing the cognitive load on programmer.
Yeah. And the shift from punch cards to time-sharing systems, that was huge for getting faster feedback. No more waiting forever to see if your code even worked.
Talk about a productivity boost. And in those evolving environments, we see the first glimmers of the tools we take for granted today, the earliest text editors, right? Starting with simple line-by-line interfaces, then slowly adding basic navigation or search features.
And the first debuggers.
Right, letting you pause execution, peek into memory. These seem like small things now, but they were crucial for making sense of what the code was actually doing.
Oh, totally. It was like shining a light into this black box of running code.
Which brings us to a really fascinating project from MIT, The Programmer's Apprentice. This was in the late 70s, early 80s. Our sources call it one of the earliest AI-assisted programming tools.
Ambitious goal, right? They
Yeah.
wanted to simulate a junior programmer who actually knew what they were doing.
That's fascinating. So how did they approach that? What were some of the key ideas behind The Programmer's Apprentice?
Well, they realized that there are these recurring patterns in code, this expert knowledge that programmers build up over time. And they wanted to capture that knowledge in what they called programming plans.
Programming plans, okay.
Yeah, basically abstract representations of common tasks and strategies. The idea was you'd give the apprentice a high-level goal, and it would use its knowledge of these plans to generate the code for you.
So kind of like how we give instructions to AI assistants today.
Exactly. It's an early form of what we now call prompt engineering. You had to describe what you wanted in a way that the apprentice could understand, and it would then map that to its internal knowledge base.
That's remarkable for the time. It wasn't just generating snippets, it was trying to understand the intent and apply learned patterns to build bigger pieces of software.
Right. And it highlights this early vision that programming could be partially automated by capturing and reusing expert knowledge.
Even though it was limited by the technology of the time, it laid some important conceptual groundwork.
For sure. It showed that AI could potentially understand and contribute to the higher-level aspects of software development, not just the mechanics of writing code.
Okay, so we've gone from machine code to high-level languages and these early development tools. Now let's jump ahead to the late 20th century. Personal computers take off, and the integrated development environment, the IDE, becomes a thing.
Bringing all those tools together in one place.
Exactly. And for professional developers, two features in particular become essential: syntax highlighting and code completion. Let's break down how those worked and why they were so important.
They seem simple, but they had a huge impact on coding speed and accuracy. Syntax highlighting, basically, it's about visually parsing the code.
Huh.
Keywords, variables, different elements get different styles, so it's easier to read and understand.
And our sources point to LEXX, the live parsing editor from 1985, as the first one to do this. Developed for the VM operating system, funnily enough, during work on the Oxford English Dictionary. What was so special about LEXX's approach?
It was all about live parsing. Unlike later systems that might just use simple pattern matching, LEXX actually understood the grammar of the code as you were typing. So the highlighting wasn't just superficial, it reflected the editor's real-time grasp of the syntax.
So you could see errors almost instantly.
Yeah, like a missing semicolon or a misspelled keyword. It was incredibly valuable for catching those little things early on.
Yeah.
And this emphasis on live feedback, that was a big step towards the interactive nature of modern IDEs.
Right. And while LEXX was pretty niche at the time, the idea of live parsing for better code understanding and presentation eventually became the norm.
Definitely, it's everywhere now.
And building on this idea of interactive feedback, the next big jump was in code completion. We had some basic autocompletion before, but the mid-1990s brought context-aware code completion. Microsoft's IntelliSense, released in '96 with Visual Basic, that was a real game changer. So how did IntelliSense actually work, and why was it so revolutionary for developers?
It was much smarter than just suggesting words that started with the same letters. It looked at where you were typing the object you were working with, the scope, and offered completions that actually made sense in that context. So you'd get relevant variables, methods, properties, keywords, and it would also show you the parameters a function expected, even little documentation snippets.
So you didn't have to keep looking things up or rely on pure memory all the time.
Exactly. As libraries and frameworks got more complex, IntelliSense was a lifesaver. It really reduced the cognitive load of remembering all that stuff.
It's all about minimizing the mental effort. And on that theme, the early 2000s saw IDEs like Eclipse and IntelliJ taking this even further, especially for Java. They had this intelligent code completion that could suggest things based on the specific type of object you were dealing with.
Oh yeah, much more contextually relevant.
And Eclipse even had a plugin called Code Recommenders that tried to be even more proactive. It would suggest API calls that were commonly used in similar situations within the project or even across the wider code ecosystem.
Right, like learning from how other people were using the APIs.
And there was academic research happening in parallel, looking at how project history and general code usage patterns could make those suggestions even more accurate.
So many possibilities opened up.
So, putting it all together, syntax highlighting and code completion really boosted code comprehension and writing speed. The visual cues made it easier to understand the structure and spot errors, and code completion meant less typing and less mental effort.
But it's important to remember, all this was based on hard-coded rules and pattern matching. There wasn't any real learning from vast data sets of code, not yet.
That's a crucial point. These late 20th century IDEs were great at automating the mechanics of coding, but they didn't really grasp the meaning or intent behind the code.
They were powerful syntactic assistants, but not much more than that.
Okay, now let's move on to the 2010s. This is where machine learning really starts to make its mark on coding. And it was driven by a fascinating realization. Despite all its complexity, large code bases are surprisingly predictable.
Right. That's when things started to get really interesting. In 2012, there was this groundbreaking paper by Hindle and his team that introduced the idea of the naturalness of software.
Naturalness of software. I like that.
Yeah, it's a cool concept. They showed that code, just like human language, is highly repetitive and predictable. They even used a relatively simple language model, an N-gram model, to predict the next token in a sequence of code. and it works surprisingly well.
So instead of just relying on grammar rules, these statistical models could learn from tons of real-world code and suggest things based on how likely they were to appear in a given context.
Exactly. And early experiments showed that by looking at real coding practices, these models could often outperform the traditional rule-based systems in terms of accuracy and relevance.
It was a paradigm shift. Code completion was now being driven by learned probabilities, not just static rules.
And this opened the door for the first wave of what our sources call ML-based code assistants in the mid-2010s.
Like Bayou, the project from Rice University in 2018, Bayou used deep learning to actually generate code snippets, not just suggest completions. That's a pretty big step. Let's talk about how they trained Bayou and what made it unique.
Bayou was trained on millions of lines of Java code from GitHub. And the cool thing was, you didn't have to give it a super detailed specification of what you wanted. You could just give it a few keywords or a high-level prompt, and it would try to generate code that did what you wanted, especially for tasks that involve tricky API interactions.
So it was focused on those parts of Java where remembering the right API calls and parameters can be a real pain.
Exactly. They pointed out that traditional code generation systems often needed specifications that were almost as complex as the code itself. Bayou aimed to be more intuitive, more example-based. It learned from all that existing code how to use APIs together to achieve common tasks.
It was like it was starting to understand your goals as a programmer, not just the syntax.
Right. It was an early experiment in going beyond syntactic assistance to helping with the logic of how to actually do things, at least in that specific domain.
And then you had startups like Kite, founded in 2014. They had this AI-powered coding plugin that used machine learning, later deep learning, and it integrated with popular editors like VS Code and PyCharm. They marketed it as AI autocomplete for Python, and they built up a pretty big user base. What does Kite's story tell us about the state of AI code assistance back then?
It's an interesting case study. They clearly had a lot of potential, but they ended up shutting down in 2022. The founders said the tech wasn't ready for full autonomy, and they had trouble making money. It shows that early AI code completion, while promising, still had some kinks to work out.
So the tech was advancing, but the user experience and the business model weren't quite there yet.
Exactly. It was a period of figuring out where AI could really add value and where it was still falling short.
Okay, and then around 2019, things start to take another big leap forward with these new natural language models. Deep Tab 9, which came from the earlier Tab 9, was one of the first to use OpenAI's GPT-2, a transformer network, fine-tuned on a massive data set of CLIN. For our listeners who are into NLP, can you quickly explain why this shift to transformer models was so significant?
So transformer networks, unlike those older RNNs, they're really good at understanding relationships between things that are far apart in a sequence. In code, that means the model can see how different parts of your code fit together, even if they're not right next to each other.
So it gets more context.
Exactly. And GPT-2, being this huge language model trained on tons of text and code, already had a good grasp of how programming languages work. Fine-tuning it on code just made it even better at generating completions that were not only syntactically correct, but also semantically relevant.
And developers were blown away by Deep Tab 9. They were using words like amazing, insane, mind-blowing. It seemed like AI code completion was finally getting really good.
It was a noticeable jump in quality. GPT-2's ability to grasp those deeper patterns meant that Deep Tab 9 could often complete entire lines of code, even small blocks, in a way that felt intuitive, almost like it was reading your mind.
That wasn't just matching keywords anymore. It was actually inferring your intent.
Yeah, and that was a big deal. Training on these massive data sets, combined with the power of transformers, allowed these models to move beyond simple pattern matching and start to actually understand what the developer was trying to do.
Okay, so the 2010s laid the foundation, proving that code is predictable and introducing those early ML-powered tools. Now let's move into the 2020s, where AI pair programming really takes center stage. GitHub Copilot launching in beta in mid-2021, that was a major moment.
Copilot is a real step up in both capability and adoption. It's developed by GitHub and OpenAI, and they call it your AI pair programmer. It's powered by OpenAI's Codex model, which is basically a specialized version of GPT-3 trained specifically for code.
And it integrates seamlessly into editors like VS Code and the JetBrains IDEs. And unlike earlier tools that mostly focused on single-line completions, Copilot can generate whole functions, even write code based on what you describe in your comments. It seems to understand the bigger picture much better.
Oh yeah, it definitely does. You write a comment explaining what you want a function to do, And Copilot can often just write the whole thing for you. Function signature, logic, even basic error handling. And it's not just snippets. It can produce much larger, more complex chunks of code.
And it seems to work surprisingly well. It's trained on billions of lines of open source code, and it often comes up with solutions that are actually idiomatic and correct. GitHub says that in files where people use Copilot, it's generating something like 40% of the code, at least for popular languages like Python.
It's wild. And it's not just about speed. Surveys show that over 75% of Copilot users say it helps them stay focused and get into that flow state because it takes care of the tedious stuff.
It frees you up to think about the bigger picture, the design and architecture.
Exactly. Plus, a lot of people are using it to learn new things. It's like having an expert on hand to show you how to use a library or remind you of some obscure syntax.
It really does seem like the realization of that programmer's apprentice vision. You get guidance and assistance tailored to what you're doing.
For sure. And alongside Copilot, you have Amazon's Code Whisperer, which came out in preview in 2022 and then went generally available in 2023.
Code Whisperer, another big player in the AI pair programming space.
Yeah, it does a lot of the same things as Copilot, like generating functions from comments or a few keystrokes. It's also trained on tons of code, including a lot of Amazon's internal code, in addition to open source stuff. But one thing that sets Code Whisperer apart is its focus on building cloud applications,
Yeah.
specifically for AWS.
So it helps you use AWS APIs correctly and efficiently.
Right, and Amazon has made a big deal about code security and reference tracking in Code Whisperer, which is really important, especially for companies.
So it can tell you if a suggestion is basically copied from open source code, and it gives you attribution links, which is crucial for licensing.
And it does security scanning to spot potential vulnerabilities in the code suggestions, which is a big concern as AI gets more involved in writing code. It shows that they're thinking seriously about the security and reliability of AI-generated code.
And then there's OpenAI's Codex itself, which is what powers Copilot, but it's also available as an API and integrated into other tools like Microsoft's Power Platform and Visual Studio. It sounds like Codex can do more than just assist with coding in an IDE.
Oh yeah, it's pretty versatile. It can take natural language prompts and generate code for all sorts of things. They've shown it creating simple games, making data visualizations, even building basic web apps, all just from descriptions. And it's being used in those conversational AI agents that can respond to requests like, create a React component for this thing.
So you're not just writing code, you're basically describing what you want, and it
Yeah.
figures out how to build it.
Exactly. That blurring of the lines between coding and just describing what you want is a really interesting development.
And then we have DeepMind's AlphaCode, which made headlines in 2022 for being able to compete with humans in programming challenges.
AlphaCode is a whole different beast. It's not an interactive assistant, it's more like an autonomous problem solver.
Mm.
It can tackle complex algorithms, the kind you see in competitive programming contests, and it can do it at a level that puts it among the top human competitors.
It's crazy how good it is.
It works by generating a ton of possible solutions and then testing them against the problem's requirements to see which ones are actually correct. It's not something you'd use in your day-to-day coding, but it shows that AI can handle really abstract and challenging problems in software development.
So taking a step back, looking at the impact of these AI pair programmers, our sources talk about big productivity gains, developers feeling happier and more focused. It seems like it's all about offloading the tedious stuff so you can concentrate on the more interesting problems.
It's about augmenting human capabilities, not replacing them. And that's what we're seeing in the feedback from developers. These tools help you write code faster, they give you guidance when you're stuck, they take care of the boilerplate, and they free you up to think about the bigger picture.
And adoption has been pretty rapid. Millions of people are using Copilot, it's showing up in education, and you have strong competition from Code Whisperer and Google's Cody. It feels like AI pair programming is here to stay.
Yeah, it's becoming the norm.
Yeah.
And it's a natural stepping stone to what we're starting to see now, this idea of vibe coding.
Vibe coding, that's a cool term. Our sources describe it as coding through a conversation with an AI agent. The agent does most of the actual coding, and you guide it with high-level instructions.
It's about shifting the focus from writing code line by line to giving instructions in natural language. The AI takes those instructions, figures out what to do, generates the code, and then keeps refining it based on your feedback.
And the term vibe coding itself, apparently it comes from Andrei Karpathy, the AI researcher. He coined it in early 2025 to describe this more intuitive, fluid way of building software with AI.
The basic idea is to just tell the AI what you want, like you're talking to a colleague, instead of manually writing everything out. And this is possible because of the advancements in those chat-based AIs like ChatGPT. They're really good at understanding natural language and generating code.
So it's not like those older tools where you'd give a single line prompt.
Right.
These agents can maintain context over whole conversation and tackle much more complex tasks.
Right. You could literally tell it to build a whole web app, front-end, back-end, database, everything, all in plain English. And it would generate the code and keep refining it as you give more feedback. It's much more interactive and iterative.
And we're seeing platforms like Replit building these chat GPT-like agents right into their development environments. They're explicitly saying they want to make building apps accessible to anyone, even if you don't know much coding.
It's a huge opportunity to address the talent shortage in the software industry. If people can just describe their ideas and the AI can handle the technical details, it could open up software development to so many more people.
It's pretty exciting. And Andrew Ng even launched a course on Replit in 2025 called Vibe Coding 101, focusing on how to work with these AI agents.
That tells you something about where things are headed.
It does. So the big difference between these vibe coding agents and the more traditional assistants like Copilot is the level of autonomy and interactivity.
Right. It's not just about completing lines of code. These agents are taking high-level instructions and trying to create complete solutions. They're engaging in this back and forth with the developer, constantly refining the code based on the feedback they get.
Steve Yedge called this chat-based coding, and he said it creates this continuous loop that's fundamentally different from how we used to code.
The AI is more like an independent agent that makes decisions about the project structure, the libraries to use, the boilerplate code, even when to test and debug, all based on your instructions.
And we saw some early versions of this with projects like AutoGPT back in 2023. Those were basically fully autonomous AI agents that could chain together coding steps to achieve a goal without much human intervention.
They weren't perfect, they could get stuck sometimes, but they showed that it's possible for AI to handle these more complex coding tasks based on high-level prompts.
And the potential use cases are pretty mind-blowing. Imagine a product manager being able to just chat with an AI and create a working prototype of an app without writing any code themselves.
That's the power of this approach, and even for seasoned developers, it can be incredibly useful for exploring new APIs, tackling complex algorithms, or even just getting help with debugging or design.
And then you have tools like OpenAI's Code Interpreter, which integrates these agents with code execution environments. So the AI can not only write the code, it can run it, generate visualizations, and adapt based on the results.
It's all happening within this conversational context, which is really cool. But it's important to remember vibe coding is still very new.
It's not mainstream yet.
Right. It's generated a lot of buzz in the tech world, but a lot of people still haven't even heard of it. And there's still a lot of discussion about what it actually means and how to do it well.
Companies are experimenting, startups are popping up. We're seeing this evolution from text editors to IDEs to AI pair programmers, and now to these AI code developers that we interact with through conversation.
It's a natural progression, but it's moving fast.
It is. And the potential impact is huge. It could completely change who can create software and make the whole process much more accessible.
Imagine a world where anyone can bring their ideas to life, regardless of their technical skills. And for professionals, it could automate a lot of the grunt work and free us up to focus on the more creative and strategic aspects of software development.
But we also have to think about the potential downsides. If AI is building entire applications, the risks of errors, security vulnerabilities, and ethical issues could increase.
We definitely need to be careful. We'll probably see new testing and verification tools specifically designed for code written by AI. And issues like insecure dependencies, data leaks, and bias in the code, those are all things we need to address.
It's a new world, and we're still figuring out the rules.
For sure.
Yeah.
But at its core, vibe coding is about handing over the reins to the AI. It writes the code, you guide it.
And the early signs are pretty exciting. It could really speed up development and make building complex systems much easier.
It's a continuation of this long trend towards abstraction in software development. We're constantly finding new ways to tell computers what to do without having to spell out every little detail.
And we're starting to see courses and tools pop up to help people learn this new way of building software.
It's a whole new skill set to master.
This has been a fascinating look at the evolution of AI-assisted coding. We've come a long way from those early days of machine code.
It's amazing to see how far we've come.
And the key takeaway for all of us software engineers is this: the trend towards abstraction and automation is only getting stronger. Every step along the way, from high-level languages to the AI tools we have now, has been about making software development more efficient, less error-prone, and more accessible.
We've gone from simple syntax help to AI that can suggest and even write significant chunks of code, and now to these AI agents that we can talk to and guide. It's changing how we think about building software.
And it's not just hype. The research backs it up, and developers are seeing real benefits in their work.
They're getting more done, they're happier, and they're able to focus on the more challenging and rewarding aspects of their jobs.
So what's next? AI is only going to get more integrated into our tools. We might see AI that helps with design, automated testing, even AI agents interacting with each other. And vibe coding could become the standard way of building applications.
Imagine just describing what you want and letting the AI handle the rest. It's a powerful vision.
It is. But we have to remember the human element. We need to be the ones guiding these AI partners, ensuring that they're building software that's correct, secure, and ethical.
It's a collaborative future, but we need to be smart about it.
Absolutely. And on that note, here's a final thought to leave you with. Given how quickly this field is evolving and the potential of this new vibe coding paradigm, what new skills do you think software engineers will need to thrive in the next decade? What will be the essential skills beyond knowing specific languages and algorithms?
It's something to think about. The landscape is changing fast, and we need to be ready.
Thanks for joining on for another deep dive. Until next time, keep innovating.
And keep learning.